This video is the fully worked out solution to problem number 66 on page 122 of our Precalculus textbook. If you're wondering what book we're using because you stumbled upon this video through YouTube, I've provided a link to it in the video's description, but if you were assigned this video, then that's a different story. You keep watching. Now, in this situation, we have the problem which states that a Norman window is constructed by adjoining a semicircle to the top of an ordinary rectangular window, as we can see in the figure. The perimeter of the window in this particular case is 16 feet. Part A is asking us to write the area A of the window as a function of x. So we're starting off with determining what is the area of the window. So the area of the window is comprised of two parts, the area of the rectangular portion and adding that to the area of the semicircular portion. So the area of the rectangle is going to be, if we focus in on this diagram a little bit more, the area of the rectangle is going to be the width of the window, which is x, times the height of the window, which is y. So we'll go over here and go ahead and write down x times y for the area of the rectangular portion. But now coming back to the diagram, we got to figure out what is the area of that semicircular portion instead. So the semicircular portion has some radius that we need to take into consideration here. And the radius in this case is going to be half the width of the overall window. And the width of the overall window being x, the radius is going to be half of x. So if we wanted to add the area of the semicircle here, we're dealing with half of the area of a circle, which would have been pi r squared. So pi r being the radius. But in our case, r is half of x. So we have xy plus 1/2 times pi times x over 2 squared. So if we go ahead and simplify that one step more, we'll get xy plus 1/2 times pi x squared over 4, which can even further be simplified into xy plus pi x squared over 8. Now, the problem we have here is that our function a of x, because we're trying to find area A as a function of x, a of x is equal to xy plus pi x squared over 8. So this is temporarily our function. But the problem is we have a variable y that's still in the midst that has to be replaced. But what do we end up replacing it with? We need to find another expression given the dimensions of the window and the perimeter in this case, to figure out a new expression for y that we can go ahead and replace it with in the highlighted function here. So what we're going to do is go ahead and analyze the perimeter of our window. And the perimeter in this case is a particularly interesting one because when we're dealing with the perimeter here, we're actually not going to be counting this middle bar. So instead, the only portions we are going to be taking into consideration are the rectangular portion down here, so this length, that length, and this portion. So for those highlighted regions, the perimeter is going to be 2y plus x, since there are two vertical portions and one horizontal portion, so that's going to be the 2y plus x so far of our perimeter. But the other portion of the perimeter is going to have to be the circumference of that semicircular portion here. So the semicircular portion right here has to have some sort of circumference we'll take into consideration and add to the perimeter. So normally when you have a circle, the circumference is going to be 2 pi r in a regular circle case. But because now we only have half that circle, we have to cut this expression for the circumference in half. So we'll divide that by 2, and so we get the circumference for the semicircle to be pi times the radius. But because, again, in our situation, the radius was half of the width of the window, which was x, we can say that the semicircular circumference is pi times x over 2. So we'll bring that in and write down pi times x over 2. So now our perimeter is equal to 2y plus x plus pi x over 2. But in the original problem statement, it says the entire perimeter of the window is 16 feet, which means this perimeter word right here can actually be replaced by the 16. So we'll say 16 equals 2y plus x plus pi x over 2. And now we can solve this equation for y right here, and whatever we end up getting is going to replace the y in this equation. So let's get started with solving this equation right here for y. So we move everything that doesn't contain a y into the other side of the equation. So that's going to give us 16 minus x minus pi x over 2 equals 2y. So the next step would be to divide both sides of the equation by 2 to eliminate this 2 right here so we can get rid of it. So we're dividing 16 by 2. That's going to give us 8. Dividing x by 2, that's going to give us x over 2. And we're dividing this by 2 as well, which is going to give us pi x over 4. That's equal to y. Now, before I plug anything in, I want to have factored as much of this as possible, just so the math is a little bit easier to deal with later on down the line here. So this is an x term and this is an x term, which means I can factor that x out from both those two fractions. So we'll have 8 minus 1/2 plus pi over 4 times x, and this is what's equal to y. Now double check the signs here just to make sure that it makes sense to you why we have a plus in the parentheses, because if we had to go ahead and redistribute this negative back, that would turn the 1/2 x, this term right here, negative, which makes sense. And if we distributed that negative over to the pi over 4, that would bring this negative into existence. So that works too. So let's go ahead and continue this solution here. Now, this is the expression that's going to go ahead and replace the y up here in our blue highlighted equation. So let's plug it in. So I have my original area equation, which is a of x is equal to xy plus pi x squared over 8. But now this is the expression for y I'm going to go ahead and plug in to this y right here. So I'll get x times 8 minus 1 over 2 plus pi over 4 times x plus pi x squared over 8. Then what happens, we can go ahead and distribute this x in, and that's going to give us 8x minus 1/2 plus pi over 4 times x squared plus the pi x squared over 8 that was already on the outside. That hasn't changed. That's still there. Now, the next thing that happens now is we can go ahead and identify that these two x squared terms are the same exact x squared, but what we can go ahead and do is, because they exist in two separate terms, we can factor that x squared out. And that's going to leave us with 8x minus 1/2 plus pi over 4 minus that pi over 8 times x squared. And here you can also double check to make sure that the distribution of the signs is making sense, because when you distribute this negative onto this term, the signs don't change here, which is exactly what we want. And when you distribute that negative onto this term, it turns positive as it was originally. So that works out too. So we go back now and try to simplify as much of this as possible by combining like terms. So we have 8x, that stays, nothing changes here, minus 1 over 2 plus pi over 8 x squared, where pi over 8 is the result of combining these two terms. So 1/2 plus pi over 8 is going to be, let's go ahead and just use a calculator to figure out the numerical value for that. So that's 1/2 plus pi over 8, which is about 0.89 if we round to 2 decimal places. So we get 8x minus 0.89x squared. A quick note here on the side, the only difference between these two lines is 1/2 plus pi over 8 was actually calculated to be approximately 0.89. Now, with that in mind, we are one step closer yet again to finally getting our function for area as a function of x. But because it's a quadratic function, let's go ahead and bring the second power term to the front so we can get a of x is equal to negative 0.89 x squared plus 8x, so that it's a little easier to look at and we don't have so many fractions to keep account of. So in this case, we have our quadratic function for the area of this window. Anytime we're given a quadratic function like f of x equals ax squared plus bx plus c. Now keep in mind, in our situation, there is no c term here, so we don't have a value for c here. C is 0. But instead, what we're going to be doing here is realizing that for a given function like this one, the vertex can be determined at negative b over 2a and f of negative b over 2a. So what this basically means is that for a function like the one we have in the box here on the left, the vertex occurs at x equals negative b over 2a. So whatever y value is associated with that, when you plug that back into the function, that's the y value that gives you the maximum or the minimum. Now, in this particular situation, because our a value is negative, the vertex is a maximum. So with the vertex being a maximum, we can go ahead and say not only does the vertex occur at x equals negative b over 2a, but in reality, the maximum of this function occurs at that value. So x equals negative b over 2a. Now, we know the value of b. That's this number right here in front of the singular x term. And the value of a is negative 0.89. So let's go ahead and write that down on the side here. So a was negative 0.89 and b is positive 8. Now keep in mind there's no c value, but I'll just keep that on the side note here, and I'll just say that c is equal to 0. We're not going to need it, but if there was a c term like this one, we would have known what it is. So now let's go ahead and plug in those numbers here, and we should get x is equal to negative 8 over 2 times negative 0.89. So when we plug that into the calculator, we'll get negative 8 divided by 2 times negative 0.89. And that gives us a value for x of 4.49. So if we go back to the actual diagram all the way out at the beginning of the problem, this diagram here had a value for x and a value for y, or at least the dimensions were provided here. So this x here is 4.49 feet. So that's one part of the answer for which we are looking at for part B, which is asking us to determine the dimensions that'll produce a maximum area. So the maximum area we can determine by maximum of this area function. So x is 4.49 feet, which means the y value, which would have been this guy right here, this y value is actually the y value right here. But we have to just plug in 4.49 for x. So let's go ahead and take this and do the work with it. So y is equal to 8 minus 1/2 plus pi over 4 times x. But let's go ahead and just replace the fractions with a decimal so we can just calculate them out a little bit faster. So 1/2 plus pi over 4 is going to give us 1.285 times x, which is 4.49. So 4.49 multiplied by that number is going to be 8 minus 5.771. Or in other words, when you subtract 5.771 from 8, we should get the answer, which in this case would be 2.23 feet. So this is the dimension for y, 2.23 feet. So we go back all the way to the beginning of the problem and we'll say x was 4.49 feet and y is 2.23. And there we have it. A little bit of math, or a lot of math. I know you're probably rolling your eyes, but that's a lot of math, and this is the way to solve it. So hopefully this has made a little bit more sense. You can take some time to review the problem as you need, and let me know if you have any questions.